All right, guys, we're going to talk about more about solving inequalities today. And just as a refresher, if you missed class on Monday or you didn't watch the video for Monday, I would go back and watch it. But here's what we're talking about. We want to graph all the values for x for which x is less than 3. And on the number line, we go to 3. That's going to be an open circle because it's strictly less than, and our arrow will go to the left. In the second inequality, we want to remember with that variable written on the right, we're going to flip that around so that the variable is on the left. It makes more sense to us if our variable is on the left. And I notice the arrow is pointing at the x. When I flip it around, I flip that arrow around so it's still pointing at the x. And I read that as x is greater than or equal to 4. Greater than or equal to means a closed circle, an arrow to the right. We can solve these inequalities. We solve them almost identically to solving equations. So if I'm going to solve x minus 4 is less than 7, I would add 4 to both sides. And I would get x is less than 11. And on my number line, I would locate 11. I would have an open circle, arrow to the left. The second inequality, 9 is greater than 3x. I'm going to divide by 3. I get 3 is greater than x, but again I want to write the inequality with the variable on the left, so I'll flip that around. Arrows pointing at the x, still pointing at the x. This is a less than problem, even though it started out looking like it's more than. When I turn it around it turns into a less than. Looks like that, so no big deal, right? We know how to do that. There's one exception to the rule in terms of solving them just like equations. One thing you have to remember, and you have to remember it forever for the rest of your mathematical careers, forever and ever and ever. It's not a hard rule, but it's hard to remember. So I'm going to do just a very, very basic example here. I want to graph the inequality 0 is less than x. 0 is less than negative x. So again, I would want to turn that around so that the variable is on the left. So I have negative x and 0, and the arrow in this case pointing at the 0. I'm going to flip it that way. Well, I'm not quite done yet. This looks like it looks like a greater than problem, right? But I haven't solved for x. What I've done is solve for negative x. So I can do this a couple of ways. There is a negative 1 in front of that x, and I can divide both sides by negative x. But I'm going to do this differently. On the left-hand side here, I'm going to add x to both sides of this inequality. And when I do that, watch what happens. I get x is less than 0. This turned into a less than problem. Here is the one thing that you need to remember, and it involves when we have this negative coefficient of the x. If we're going to solve this inequality through multiplication or division, what I would do is divide by negative 1. Anytime I divide or multiply both sides of an inequality by a negative number, I have to flip that inequality sign. This would become x, this would become 0, and I reverse the direction of that inequality. This becomes x is less than 0. These two inequalities are the same thing. They should have the same answer, right? And I can do it a couple ways, by adding that thing to the other side or keeping this one rule in mind. And that rule is if you divide or multiply both sides of an inequality by a negative number, you have to reverse the direction of the inequality sign. Every single time, forever and ever, amen. This is always going to be true for the rest of math. It's going to be true in Algebra 1, in Geometry, in Algebra 2, in Pre-Calculus, in Calculus, anytime you do this. If you divide or multiply both sides of an inequality by a negative, we have to flip that inequality sign around. Again, it's not a hard thing. You just have to internalize it. I can say it 500 times, and I probably will, but you have to remember it. So let's look at a couple different examples here, okay? And they're similar to each other, but let's look at what happens here. In this first inequality, 3 minus 2x greater than or equal to 15. My first step there would be subtracting 3. Let's use a pen instead of the highlighter. There we go. Minus 3 from both sides of the inequality. I get negative 2x greater than or equal to, and that would be 12. And then I would divide by negative 2. And my answer would be x and negative 6, but because I divided by that inequality, I'm going to reverse the direction And instead of greater than or equal to, I would have less than or equal to. Again, that wasn't hard. I just have to remember it. There's my -6. That would be a closed circle, arrow this way. Now that's different from the second inequality, so let's watch what happens here. I'd start the same way. I'd subtract 3 from both sides. I have a positive coefficient here, so 2x greater than or equal to -15 minus 3 is -18. Now what I'm doing here is dividing by a positive number. I do not need to reverse the direction. Even though that 18 is negative, the thing that I'm doing, the verb that I'm doing, the action is dividing by a positive. So I keep that inequality going the same direction. Okay? So dividing by a negative or multiplying by a negative as that last step, flip the inequality. If it's just divide or just multiply, we don't flip it unless it's a negative. So I want to show you types of inequality problems you're going to have in your Delta Math homework tonight, all right? I believe this is due Tuesday night. First part says, which of the following values are solutions to this inequality? So they've given me 3 different values, and they want to know which of these are solutions. Is it none of them? Is it choices 1 and 2? Is it, 2 only, 1 and 2? So I have to try each one of them and then determine which of these are actually solutions. Well, they're solutions if, when I substitute them in, I get a true statement. So let's see. Let me start with the first one, so -10. So my inequality is -7 is greater than or equal to 2 plus 5x. So I'm going to say, is -7 greater than or equal to 2 plus 5 times that -10? Well, let me check. Is -7 greater than or equal to, that would be 2 minus 50. Is -7 greater than or equal to -48? Yes, it is. So I know that 1 is a solution to the inequality. Now I'm going to try the same thing with the other 2 values. So let me try 3. Is, let's see, -7 greater than or equal to 2 plus 5 times 3 this time? Well, that would be 2 plus 15, that's 17. Is -7 greater than or equal to, 15. That would be 17. No, it's not. So number 2 is not part of the solution set. Now I'll do the same thing with the number -1 and check to see if that's part of the solution set. So 5 times -1, 2, that's 2 minus 5, which is -3. Is -7 less than or equal to -3? No, it's not. So my answer here would be 1 only. Let's check if I got that right. I'm going to say 1 only, submit, and I was correct. Okay, so that's the first type of problem. Okay, and then the next type of problem is what we were just talking about, solving and graphing on the number line. So to solve this inequality, first thing that I look at is I notice there's a negative in front of that x. So I'm going to have to keep that new rule in mind. But otherwise I solve it like any other equation. I'm going to add 2 to both sides, keeping it balanced. -3x is less than or equal to 12. And then I'm going to divide by -3. And I get x is now greater than or equal to -4. So they want 2 things here. They want me to write the inequality. So I'm going to click in that box. And I don't know if I can do this here, but I would type x is, so type in your x is greater than or equal to, I would touch that, oh there we go, x is greater than or equal to, and they've given me those symbols, -4. And then they want me to graph it on the number line. So what I'm going to do is click on the number line at -4, and I should be going to the right, click and drag, and I can't seem to do this on my iPad right now. Click and drag to the right and go all the way to the end of the number line. And if you need to change from an open circle to a closed circle, just touch on that, on the dot. Okay, so that's the second type of question. And that's it. So you're going to do a total of 10 problems with a little new caveat, okay? I know some of you have been using PhotoMath to do these. I'm going to need to see all of your work done out for each of the 10 problems, all right? So you're going to do these problems out, take a picture of each problem, and we're going to upload that into Schoology, all right? Some of you using PhotoMath has kind of ruined it for everybody else, but I need you to know these skills. I know you can't do these problems in 10 seconds like I'm seeing in Delta Math. All right, so that's it for Thursday, guys. Have a good afternoon. Bye-bye.